Hello, my name is Julian, and today I'll be presenting TILIXI, a lightweight OS that I've been developing over the last couple months, which is running on an ESP32 with a terminal-focused design. Everything's basically just a terminal in this project. So here I will demonstrate it. First, it'll boot in, and you'll be put into a login screen. So user identity is really simple. Here, let me just put in a wrong password. It'll check just to prove that it can detect passwords. So user identity is very simple. It's file backed, and it basically just copies from Unix, where the password is stored in etc/password, and that determines the user home and the password. That's just where the password is stored. Let me just demonstrate some Unix functions. So let me make this a little bigger so you can see. Let's just list the current directory. Let's make a directory. Let's make test. So directories and files are all handled through a virtual file system. This just means this is just so higher level code doesn't depend on any SD gimmicks. I actually didn't write this in ESP IDF, so anything regarding any libraries that are written on a different hardware, I want to mandate all of that myself in a virtual file system. So now that we're in the directory, we can list. There's not going to be anything since we just created it. Let's create a file. Let's create test.txt. Alright, so file creation again uses the virtual file system API, which is the entry point for these storage operations. And now let me edit this file with nano. I'm sure you recognize that term. Check that as well. So this editor enters like a full screen within the terminal, and it'll still take inputs rendered. So let's say, hello world, have a nice day, good job, aces. Now you can see that's been modified. We can exit, yes, or sorry, X, Control P, X, yes, we want to save the changes, and let's exit. Okay, so now that this file exists in the directory, we can take the contents of the file and we can print it out. See, it's all there. As another built-in command, we can do some basic utility like echo hi. This will of course print hi. And we can also grep for simple file searching. So let's look for have in test.txt, and it will return the line of which have occurs. It's perfect. And we can also find the absolute path of where we're in using this command. We're in home / that's the username I chose / test. And now to show this is persistently stored, let's just reboot. Log back in. Oops. Zoom back in again. I don't want to be like this. And this isn't gonna wrap around. We can just enter test to show. That's something I still need to correct. Sorry, it's cd test. And here's what we created prior, test.txt. We can make sure it's still there. Voila, it is still there. So let's move this file out of the directory. Let's move test.txt out of the directory. Let's list to make sure. This directory is empty. And now we can actually remove this directory. We can delete the directory with remove directory. test. I'll zoom out just to, sorry, wrong command. I'll zoom out so I can prove that it's there. You can also see the test from the original list. See, it's gone, and now we just have test.txt, which is normally removed like that. And again, I should mention all this passes through the VFS API, virtual file system. So I should just mention that again, don't forget. Now let's, I should show pipelining. So let's clear this. Now let's pipe the output of lists to a new command, word count, and let's specify word count lines. It's not actually going to show the lines that's printed, it's going to show how many files, but yeah. So let's see how many files there are. There's 8. And if you want to confirm, I'll just do this. If you really care, you can count 8 there. But that just shows how pipelining works. So the output of one file is going to go to the input of another. Yeah, it just works like a traditional shell. Let's go into the config. This is going to show user customization. So let's go into config, and let's go into fast fetch. You may recognize that term if you use Linux. So fast fetch, this is where you keep the user inputted assets for the fast fetch command. So right now we have an image here. This image is called fetch.rgb565. Let me remove that. That was just me testing a little while ago. Now I'm going to show you something pretty cool. Image V. You may recognize this from Linux. This is a little image viewer which takes in an RGB565, which is just a raw image file. At the moment, it doesn't actually display red, green, blue. It just displays one color, so it loads a little faster. But I hope to get it to display a full red, green, blue later. But yeah, anyways, as you can see, it actually renders an image. I made this image render. I didn't use like tiny JPEG or anything. I made this image render, which actually makes it sound a lot harder than it is. It's really easy dealing with raw files. I thought it'd be a lot harder. Anyways, let's clear this, and let me show you what fast fetch actually does. So let's zoom out a little bit, and let's run fast fetch. That shouldn't be happening. Okay. It may be taking AF right now from prior. I'll reboot and check it if it works. Alright, sorry about that little hiccup. Let's get back to it. I'm going to demonstrate user customization. So let's go back into the config. And now let's go into our TILIXI config. This isn't very verbose at the moment, but it is some customization. Oops, I may have overtyped. Yeah, wait. Sorry, it's a little difficult to type through serial monitor, but let's go here and let's go to the end. And now let's change our active color to, let's say, red. That should look nice. And now let's confirm. And now if we actually do this command reload, which will refresh our config, we will see we actually get a red active color. So our text is red and our terminal border is red. So now if I run fast fetch, would you look at that? It looks all nice, and oh, I didn't even talk about fast fetch. So fast fetch displays the operating system, your host, which is your hardware, uptime, the shell. Shell is Damocles, that's why I named it. How much RAM we're using 18% of our RAM, and how much of the disk we're using. Disk is our SD card. See, we're not actually using a lot, that's why we're using raw files. It makes take a lot more space on disk, but it's significantly faster to load. Anyways, next thing to showcase, let's leave here. Let's get out of the config. And now let's go to scripts. So I'm gonna show you the Lexer I made. Let's see, scripts. Now, writing a script would take way too much time on this, so I'm just gonna go to one of my preset ones. I think main showed conditionals, I believe. So this is a pseudo shell script, I guess. It's not a complete shell script because it doesn't have everything that you'd want from a shell script. However, you still can do variables, like you have name equals JDS, count equals 1, and it'll, at the very start, it'll echo name is the variable name. Conditionals, if echo, if branch, so this will just create an if statement, which will echo if, and then it'll echo elif, and then it'll echo else when we're in the else. I don't believe else will work here. I think I may have miswrote this script, but let's see. Let's exit, and let's run main.sh. Yes, so as you can see, it'll say name is the variable JDS, and it'll print the if branches. Else wasn't implemented correctly. I'm sorry about that. And that's about it for the demonstration. This is getting a little long, so I'll start explaining how everything actually works. Now to explain the operating system conceptually. So TILIXI is a lightweight operating system built around a terminal interface. At the center is the terminal subsystem, which owns the user session and which also handles the screen buffer, input editing, window layout, command history, and rendering. Every key press goes through the event processor and then either triggers a hotkey or lands on the terminal's input handler. Hotkeys are a separate control layer, which they map the key combinations to named actions like opening or closing terminal windows or changing the active selection. The action manager keeps a registry of those named behaviors, so input routing stays decoupled from execution logic. When the user submits a command line, the terminal passes it into the shell, and the shell tokenizes the line, dispatches a built-in command, or it can run the script interpreter for multiple commands, and then, So the shell actually doesn't manage input or rendering, it just sends it to the terminal, which does all that stuff. Processes are tracked in a central process registry. Each process has a compact control block with state priority, entry point, and runtime data, or runtime metadata if you want to be precise. This gives consistent execution for built-ins, scripts, and the, runtime. And onto the virtual file system. So all storage flows through a virtual file system layer. The virtual file system is a mandatory boundary between high-level code and the SD card. It's commands such like lists, cat, make directory, they never actually talk to the SD card directly. They only operate on a higher level virtual file system node, and that node handles file handles. This makes the file system logic much simpler and consistent across the system. This could arguably be more consistent if I wrote the project in ESP-IDF and used the proper ESP-IDF SD, but that's in the past. I'd probably still use a VFS even then, just for a proof of concept. Next, the boot is structured as explicit stages. The system brings up the display, it initializes storage, loads core services, registers commands and hotkeys, and then finally enters the main event loop. If something fails, like maybe the SD card didn't mount, or there's no SD card, or I don't know, something failed silently, the boot layer drops into a minimal TTY. You can think of it as an emergency TTY, which will say exactly what went wrong, and that's kind of about it. You can't really fix any of this stuff with the current operating system. Like, you can't run C code. So it is kind of just a proof of concept. There's no real way of fixing anything. Then finally, onto user customization, which is the last thing I want to talk about. It's handled through per user configuration files in the SD card. The things like the shell history is stored under a .config path, logos, I don't know. Yeah, they're all discovered under the user directory. And all of these things, like the color, the images, everything under the config is reloaded at runtime or through the reload function, which just does what happens at runtime, just without a full reboot. And yeah, and that's about it. Thank you for watching. I hope this inspired you to go into or look into more operating system development.